Hello everyone, Sharif here. In this video, I'm gonna present to you the Quantum Silicon Loader or the update of my qslcl.bin and its features, its functionality, and what layers that QSLCL targets. So, for my previous video about the qslcl.f and the old qslcl.bin, which also have a bit of inaccuracy, but from now, which also the update and the version is 6.7, it is now much more efficient and much more professional than the older one. So let's start. So what is qslcl.bin? The qslcl.bin is a universal binary payload that executes directly from RAM, which is what I call the random access memory, and it is remain writable and no signature requirements, and it works of all SoC including Apple, Qualcomm, MediaTek, Unisoc, and generic devices. And also it takes over USB controller after upload, and it provides 20 plus low-level hardware commands like read, write, erase, poke, pick, glitch, voltage, and so on. And also my qslcl.bin runs on any architecture, which is the ARM, x86, RISC-V, MIPS, and the PowerPC. And my qslcl.bin works in DFU, EDL, BROM, and engineering modes, and also in addition the unknown or generic USB devices. Its key principle is it's not a exploit but a standards compliant USB payload, and also my loader cannot be patched or blocked by the vendors because it uses intended features, and also it remains future proof as long as RAM is readable and also functionable in many modes. Here its core features. My loader have a micro VM engine with the header called QSLCL VM5. It contains the 50 plus opcodes or my custom instructions, which you can see in my build.py, which creates the qslcl.bin. And also it has a memory management unit, MMU, simulation, which also part of the micro VM. And also it has a inter-process communication or IPC, and also it has a multitasking with context switching and cryptographic primitives, which also I have a the multiple cryptographic hash embedded in my loader, which is the ChaCha20 AES, RSA, and HMAC. And the USB micro engine, QSLCL USB, which also have inside of the qslcl.bin, and it has a complete USB stack in RAM. It has a control, bulk, interrupt, isochronous endpoint, which also the 64 endpoints, as you can see in my build.py if you see it. And also it has a dynamic descriptor modification, which also prevents the alignment issues sometimes, because most likely when building the Python script is not accurate if the code itself has a bug, or it's not actually the non-functional, but most likely when I code it has a the bug or minor issue which need improvement. And also it has a self-identifies as QSLCL loader. Next, now this is the data protocol that qslcl.bin have, and it has a header called QSLCLDATA plus QSLCLSYN, which also the synchronize. In my data protocol, it has a chunk transfers with sequence numbers, and also it has a ACK or NAC, which also the acknowledgement system, the CRC32 verification per frame. When running some of the headers, it needs to be verified by CRC32 to prevent some alignment issue or some invalid operation, which also creates errors when running the qslcl.bin while executing the qslcl.bin. And it has a resumable multi-frame transfers. Next, it has a advanced features. Number 4, the encryption layer, which also the header called the QSLCLENC. The encryption is ChaCha20 poly 1305 or also the 1305, which also the 256-bit, which also much better than the standard SHA-256 or AES, and also maybe prevent some quantum attacks sometimes. And also it has a AES-256-GCM hardware accelerated. You can see in my build.by in QSLCLENC. And also it has a session key negotiation with perfect forward secrecy or the PFS, which also every session when running the qslcl.bin while parsing the headers or execute the code, it needs to be a session key, which also randomized per execution. Now the anti-replay protection with nonces, which prevent the attacks when running the qslcl.bin. Maybe some of the execution or some of the hidden telemetry in low level mode, which is possible in some vendors to detect some unauthorized access. Now, the QSLCLENC required for Apple A18 plus DFU mode, and also it is optional for some devices like Qualcomm, MediaTek, and Unisoc, and some of the future devices. Now, the USB 4 v2.0 80 Gbps support, which also the header called the USB V or the USB 4 v2 MC. It has a PAM for encoding, 2 bits per symbol, and also it has a 4-lane aggregation, 40 Gbps per lane. Now, it has a PCIe DisplayPort, and also the USB 3 tunneling. And also it has a CMA plus DPP hardware security and sub-microsecond latency. Now, the integrity and security, which I mentioned earlier, the CRC32 to prevent some corruption, and also it detects some corruption when running the QSLCL.bin. It has a both SHA-256 and also the SHA-512 and HMAC SHA-512 for stronger authentication, and the Merkle 3 for partial verification, and multi-hash cascade, which also the quantum resistant. Now, here's the layers that QSLCL targets. As for now, you can see in the layer, it is also below the bootloader, below the secondary BootROM, but it is above primary BootROM, which is also the read-only. The my QSLCL.bin runs in layer 1.5, which also between this one, secondary BootROM and primary BootROM. In secondary BootROM, which is the SBL or the primary bootloader, and the primary BootROM, which is also the mask ROM or typical BootROM, which is also the read-only memory. And the below is the silicon, which also maybe some circuits or on how the USB controller works, or also it contains some RAM execution which needed for device functionality. So you can read it here. So it cannot be blocked without redesigning silicon. Now, what modes that QSLCL targets? First of all, it targets the Apple DFU in 812 into A18 plus, and It has a USB DFU class FE01 detection. You can find it in my qslcl.bin, and and it doesn't contain hard-coded fields, which also have typical change when Apple update the iOS. And also the RAM execution via standard DFU download, you can see here. And also in A18 Plus requires encryption. Depends in models, but it is optional if needs to be future proof. Now in Qualcomm EDL, or the emergency download mode, the Sahara and Fars protocol, typical my qslcl.bin have custom protocol, but since that my qslcl.bin runs in RAM, it will execute correctly. And also, as you can see, in DDR, it executes the RAM, and also the optional encryption support with the QSLCLENC. And also in MediaTek BROM, or the preloader, the preloader handshake is A0. Actually, my qslcl.bin has a custom instructions, or the micro VM, which also bypass this handshake. And the execution is SRAM or DDR, and it replaces the download agent entirely. Now in Unistock BROM, Samsung EUB, and the generic USB, it has a endpoint auto discovery. You can find in my qslcl.py, and also the fallback to standard USB CDC book if you're using the old devices. Now here's its commands. There's so many commands. There's memory operations, read, write, erase, pick, poke, patch, dump. Now in system control, it has a reset, power mode config. You can read in build.py features that qslcl.bin have. The device interaction, which you can try in your device, which is the hello, ping, get info, partitions. And security, it has a RAW mode, bypass, verify. And the manufacturing is OEM and ODM. For Apple devices or iOS, it is very limited to use this OEM or ODM because this is most likely works on some Android. And the advanced testing, the crash, glitch, and brute force to test the security. And each of them uses the micro VM bytecode for cross-architecture execution. Next, now this is the most common things that why my qslcl.bin is future-proof or cannot be patched. Number one is it uses standard USB DFU class request. The DFU download, this is mostly required feature, and if Apple remove it, will requires them to redesign the silicon, but it breaks the device recovery, and they can't even disable it without breaking devices or making device paperweight. Now, number two is the RAM execution is fundamental to computing. This is most important because RAM should remain writable, unrestrictable, and also accessible. Making RAM read-only or making RAM remove will break the device or will make the device unstable. And also all CPUs execute code from RAM, which also QSLCL uses the custom micro VM instruction. No signature check for RAM execution, cannot patch without breaking all software. And number two is USB controller is hardware. Registers are memory mapped. Once QSLCL runs, it controls the USB controller. Hardware cannot be changed without new silicon or hardware redesign, which also doesn't even fully block QSLCL.bin, you know. Number four, the most important thing is QSLCL is not an exploit. It doesn't use the buffer overflows, the signature bypass. Actually, my QSLCL.bin have signature but it doesn't even bypass the signature of what vendors implement in hardware. And also it's just a standards compliant communication. Here's a summary. As you can see, my qslcl.bin is universal, unpatchable, future-proof, secure, professional, and invisible. And you can see here, my loader can work in future quantum chips, and also it works from old devices from 2000s, and also it cannot be patched or fully blocked without breaking the device, and also they cannot even block the qslcl.bin without making the device unstable. And also it has a future proof. It's ready for USB 4 version 2, 80 Gbps, which also maybe your typically research from that. And also it has a secure, which also the multi-layer encryption and attestation. And it is professional, not a script kiddie thing. It has a 26 commands and structured protocol. Now it is invisible, it runs entirely from RAM, and it has no trace than writing in flash. And guys, you can see here, this is the update of my presentation, because my older presentations might be a bit inaccurate sometimes, but this update will be more accurate if possible. And also, if you want to study more, you need to read the build.py or the qslcl.bin from yourself to understand how it works and how gonna implement in your third-party tools. And also my qslcl.bin is a pathway if you want to jailbreak, access the hardware, but you need to work around on how to do it on your own. That's it guys, and see you there soon.